welcome back to AWS AI Innovation Day. I'm Jasmine Kyles, joined here with my co-host, A.M. Grabelny. If you were just watching us, he went to the store after our last session, and guess what he picked up?
It's something important.
It is our friends here to talk with us about AWS storage. Welcome to the show.
Thank you so much, and it's a pleasure to be here. My name is Marcos Perez. I'm a storage solutions architect with AWS, working with FSx for Lustre.
Oh, and I'm Laura Shepard, and I'm a storage specialist, and I work on FSx for Lustre and other high-performance storage.
Yeah, we're excited to talk about storage here today. So as we've been going through the day, we've heard from all different teams talking to us about how we are putting AI into practice with customers and all the different tools and available resources and infrastructure. So getting into storage, why is storage important to our customers? And, when they're looking at generative AI or ML and driving this adoption, what's important?
Well, with storage, there's really two major areas that we want to focus on for Gen AI and traditional machine learning. And the first one is that everyone needs a data strategy. This sounds like a very high-level statement, so let's get into what it means. What it means is if you have a big problem or opportunity you're trying to address with Gen AI or machine learning on the one hand, and on the other hand, you have a bunch of private data that pertains to that, right? Private data is, data that only you have, right? You're much more likely to take that data and invest in customization of Gen AI using it. So techniques like RAG, pre-training, refining, or even training your own models, right? Because you can leverage that data to improve the outputs. Whereas if you don't have that private data, you're much less likely to invest your Gen AI training program that way, right? And so this is something that we see time and time again, is that people who are successful, they start with a data strategy, right? And when you want to tie that back to, all right, what are we talking about? Storage, right?
Yeah.
We have to make infrastructure choices. And most people, from an implementation standpoint, they find that they implement a well-formed data lake on S3. Because S3 and the things that it integrates with provides the feature and functionality that you need for your data labeling, your normalization, your provenance, your permissions, your tracking, et cetera. So everyone needs a data strategy, and that's typically going to be best served on a well-formed data lake on S3.
Yeah.
Laura, you said two.
Oh, no, you caught me. Did you get the other one at the store?
I'll go get it.
Okay. Let us know when you get back.
I'll come. I'll stay. It's more important for me to stay.
Well, I should touch on the other one because that's where our demo is going to come in, right?
Yeah.
So that's good. So the other area is in kind of a high performance area in ML, right? So where you're training your own models, especially at scale. So typically what we see is our customers start out kind of smaller, right? They want to see if they're going in the right direction with the model parameter count and the amount of data they're training against. As they see success, they're going to grow those things. They're going to grow the model size. They're going to grow the data set size. And that can get beyond the point where training on a single compute instance can be fast enough, right? They say, oh no, it's taking too long to train my model now. What do I do, right? Well, they distribute it. So they distribute the training over multiple instances. And this allows them to take all that compute and apply it to the training problem at the same time, which makes it faster, right? This was the goal. This is what we want. That's good. Now it's faster. All right, so what's the problem? When you distribute, you can introduce data wait time, right? And this is where the storage decision comes in, right? You start saying data, you're headed towards storage because that's where it lives. So the data wait times we particularly see in distributed training are three. There's latency, right? The access to that first byte of data so you can start your job. Then there's the second one, which is bandwidth, right? How much data can I get into and out of that storage infrastructure and into and out of each one of those instances that's doing the training? And then the third one is waiting for those data copies, right? Like your last session was referring to, you got to copy the data into and out of local storage, local memory to each compute node, right? Well, waiting for those data copy wait times before you can start your job, that's another wait time. And you want to minimize these because the biggest part of your investment is compute and training.
Yeah.
Yes.
So if your compute's waiting for data, you're paying for things you're not using. And this is what we call a bad thing. So we want to minimize that, and your storage selection can make a huge difference. And so what we see in our large-scale distributed training environments, again and again, successful customers are choosing to use a high-performance shared file system as their training tier. And so what they're doing is they're using Amazon FSx for Lustre.
Yeah.
Okay.
Yeah. And Amazon FSx for Lustre, it's going to minimize that latency problem because it's got sub-millisecond latency. It's going to minimize that bandwidth problem because you can do terabyte plus per second. We're not going to do terabyte plus per second, right? We're going to do like 100 gigabytes or something per second.
Because of the time we have. But,
Yeah.
we could, yeah.
We could, but we're not going to. And then, of course, it minimizes the copy time because you don't have to wait for your data copies to complete because the data is just there. So you can start your job right away. Another really cool thing I think that Marcus is going to go into too is that FSx for Lustre is unique in that it natively integrates with S3. Which means that you can keep your data in that well-formed data lake we were talking about for your data strategy, right? But you can also access it through this high-performance distributed file system for training.
Okay.
And you can do them at the same time, which is really cool.
That's exciting. I mean, look, I spent a lot of time in the storage world, maybe around 2015 or so. And even back then, one of the most powerful things that I saw personally was decoupling storage from compute. I mean, this has like really brought about incredible innovations that weren't possible before we did that, right?
Yep.
Yes, true.
So I love seeing anything that is really optimizing and helping us use the right amount of compute for the right amount of storage and vice versa, right? Like having that completely decoupled, like Laura said, you can often spend money you don't need to spend if you are not taking advantage of that. So Marcos, you're going to take us through a demo here of taking a data lake on S3 and then bringing it to a file system?
Yeah, to your point, yes, you have to be cognizant of the storage and the performance that you can get through the file system. So as you can see here in the demo, in the environment that I have here, I have several compute nodes here that they are running. They can be running any process, and I have a head node that you control that. So how can I serve that cluster of nodes with the storage that will scale to the level that my training models or my HPC workload will require, right? So that's where FSx for Lustre will play a key role. So this is how easy it is to build a FSx Lustre file system compared to on-premises that would take weeks or even months to get together all the research to put this cluster up and running. And you can do that in a few seconds, just selecting things like capacity, type of disks and throughput that you need. So you can choose between solid state or hard drive, or have a trade-off of performance and cost. You can choose the throughput, the right throughput for your workload, and you can increase and decrease that throughput down the road if you need, because your workload doesn't need or need more throughput. So you can always, and the capacity and performance is linear here. So the more capacity you have on your file system, you see that the performance will scale in parallel with that. So if you need more performance, if you need more capacity, you can always go and increase that on your console or using CLI. Okay. So what I'm going to show here is I have a file system together already, and I use that just to show you how powerful FSx for Lustre is to accelerate your access to your data lake on S3, for example. So here's the file system, right? And this file system is created with 100 terabytes of capacity with 1,000 megabytes per second per terabyte with a total of 100 gigabytes per second of throughput on the disk. Because we have cache, you have other mechanisms in the middle that could increase that value to even more.
I just want to interject, though. Just don't be thinking that you have to have a cluster size this large to take advantage. We have customers doing this with as few as 3 nodes, for example,
okay.
and then up to hundreds. But we're showing you a nice, healthy size demo today.
Fair enough.
Yeah, and what we have on the back end of this file system here is a S3 bucket. So I have here what we call the Data Repository Association, which is quite easy to create. You just list the file system path that you are using and the S3 buckets and prefix or prefix, and then you create that relation between S3 and file system. Your S3 can be as big as you need, so you have petabytes of information there, but you just need your file system in that type of architecture on the size of your hot data. So you just size it according to the data that you are using for machine learning training or for HPC workloads, right?
Marcos, you know this is one of my favorite features also of this direct integration to S3. I don't have to sync. I don't have to sync from S3 to a file system.
That's correct. That's one of the things that consume time when you are doing that.
Tell me about
it. Right. So
I've done that.
You can, so you can import and you can export the data from the file system to S3 and back automatically for any new changed or deleted file on the file system or object on the S3 bucket. So when you do that, automatically the file system will reflect the changes. And I'll show that on a real file system here. So as I mentioned, I have a fleet of nodes here, and I have a head node, which will be my entry port to my cluster. And if I use my Lustre client here, LFS df-h, and I'll be able to see not just the capacity of my file system, but also you can see here something that's not expected. You're just seeing a small capacity here instead of all the files that I have on my S3 buckets. I'm just seeing a few megabytes being used here. And on my S3 buckets, I have more than 2 terabytes of data. Okay. So why I'm seeing this? Because I'm just having the metadata. When I connect to my file system to S3 bucket, all you see is a metadata of the file. So if I ls the FSX file system here, you see that I have the folders. Those folders are coming from my S3 bucket, but I'm not consuming any space until I need it.
Okay.
And that's another interesting feature is hierarchical storage management that you can bring the data from S3 in 2 ways. One is the lazy loading that I'm going to show you here how the lazy loading works, right? So I would take just one file as an example here, and I'll save it to a variable.
Real quick, because you mentioned the metadata also, am I to assume you mean like POSIX groups and things like that?
Exactly.
That's because S3 doesn't have the idea of a POSIX group, right?
You're right, AM. So all the POSIX information on the file will be generated and created as a metadata on the S3 object. Okay. And whenever you synchronize this back to the file system, all the permissions, timestamp, locking, and anything related to POSIX metadata will be on the object and will be available for
You are just wonderful people. Thank you.
So let's see this particular file that I chose here. So when I list that file, you see that I have 1.7 gigabytes, right? So, but if I go into that file with disk usage to see how much space this file is really using on my file system here, you see that it's just consuming 500 bytes, which means that file is not here, right? I just have a placeholder here. So as I've mentioned, the first way that you can access this file is through reading that for the first time. Okay. So when I read that, and I'm just using a cat here on the file, and I'm throwing the results on DevNode just to see how long it will take to read that file. It's taking a few seconds because I'm going to S3, bringing this file to the file system, and that's what's happening here in 8 seconds. Yeah. If I go and read that very same file again, of course, it's going to take like a fraction of a second, right?
Now it's here. Now it's in the local file system.
Exactly. But more, I'm using a local client cache here. So
interesting.
So I don't want to cheat here. So I'll remove that variable and I'll drop the cache. So I'm using a command here to drop the cache. And then I read again. Let's see how long it's going to take. Okay. Again, just 1 second. So instead of the 8 seconds, it's just 1 second, 1.5 seconds, because the file system has the data on it. Right. So that's one of the ways that you can load the data. The other way, as I mentioned there too, is the preloading. So whenever you know the information that you need, the files, the folders, you can go and preload that in advance, so you can save time in your GPU, CPU when you're running a process. So that's what I'm doing here with HSM restore command. I'm running that through the entire tree of files that I have on the file system here. It will take a few seconds, and this is generating a lot of IOPS on my backend because I'm doing that in several threads. Let's see how this is impacting on the file system. So let's go back to the FSX here, and I will go to monitoring here. And let's see the IOPS. So bear with me. Let's reduce this to the last 1 hour or so. So you can see already here there is something happening. So let's give it a second more. So CloudWatch will detect the trend. So let me open a dashboard here so we can see everything together.
As Marcos gets this set up, remember, we're live. Please put your questions in chat if you have any for Marcos or Laura. So I mean, so far, you two, this is phenomenal, right? Yeah. The things that is happening behind the scenes that you would have had to do, basically. You synchronize between these disparate places. You don't have to do that.
Exactly.
pull in the metadata. You don't have to do that. That's amazing.
Exactly.
Right. So as you're getting this going, so let's revisit this. We have some folks who are joining us live. They're coming and going, and more people are coming on. So when would you use Amazon S3 for AI ML workloads?
Oh, well, you would use it for supporting your data strategy. And you need a data strategy to support your Gen AI strategy, because if you don't know what private data you have to apply, then you don't know how you're going to be investing in customization, right? Yeah. So that's a big one. And the technique that Marcus is showing us now of preloading the data, this is kind of like what our customers who are doing large scale distributed training learn over time, is that they can preload their data, which means that they don't, as they do with other techniques, have to keep their big training cluster up, right? Because they can wait for the data to be 100% in the file system and have it at that sub-millisecond latency and really high bandwidth before they even turn that cluster on. So it can be a really big cost savings for the advanced user feature, right?
And as you can see here, we're already on the 400,000 IOPS, and this is growing. It's going to reach almost 1 million IOPS here. So while this is running, let's go to the next test that I want you to do here.
Okay.
So we just did a read, a preloading of the data. So let's now read that data across all the nodes that I have here in place, right? So I have 40 nodes, and I'm using Slurm. Slurm, for those that are not familiar, is a Linux open source tool that will allow you to schedule, process, and run that across multiple nodes.
Okay.
It's used by more than a half of top 500 supercomputers. So it's a very common tool that is used to distribute the workload across multiple nodes. And I'm using here Slurm to just do a basic read. So I'm dropping the cache so I don't cheat. And then I'm using a read process here across all the vCPUs that I have. I have 32 vCPUs in each one of those nodes, and I'm running this across all the 40 nodes. I'm sending this task to my Slurm batch, as you can see here, and now it's running. So if I list my queue here, you see that I have all my nodes running a process here for 2 minutes now, and it's basically reading all the files all over again. So let's go to the IOPS here to see what we have. So now we have here what? Let me put 1 hour here. There you go. So you see here we have 817,000 IOPS running here. And I had some 30 something gigabytes per second of throughput. But since now I'm running this big process on the back end, will take a couple minutes to show up here in the graph. But pretty much soon we're going to be able to see, you see again? Now we are beyond the 100 gigabytes per second. Remember, the file system was created for 100 gigabytes per second originally, as you can see here. And now we are running this throughput on 164 and growing at the same time. So that's the type of performance characteristics that customers that are distributing their workloads are looking for. High throughput, low latency, IOPS when they need, and then being able to do that in a simple file system with so many resources being managed automatically by the service. So as you can see here, each one of these items in this list here is one server in the back end that's being distributed the entire I/O. So and now I'm consuming the capacity here too. As you can see, I'm consuming 2.2
terabytes there now.
Yeah. So what if I finish my training? So it's finished already. I don't need to use that capacity anymore. I want to release the capacity so I can use the very same small file system for another training job. So I can use a release command here on my hierarchical storage manager. It took like 9 seconds to run, but what's doing now, it's releasing all the files from the file system back to S3, so I don't have to consume that space anymore, and I can start a new training process. So now if I list again here, you see that I just have 700 megabytes.
That's a really interesting point too, because it depends on what you're doing, obviously. But if you're treating S3 as like a read-only space and you're just pulling files into FSX for Lustre, right? You don't need those files after you're done.
Exactly.
But I also noticed, and please correct me if I'm wrong here, there was an export feature also on FSX for Lustre back to S3. So if you are actually generating new files, Is that an option?
That is correct. Yes, you can always create tasks via CLI or via command line to restore and release the data as you need. So you can preload. That's what we did in the first phase. We preload the data, and we do use the restore to preload the data, and now we use the release to give the space back to the file system. And that's what you see here in the graph. You see the capacity going down, you see the IOPS going on the 800, and you see the throughput getting almost 200 gigabytes per second, which is a lot, right?
Yeah, sure is.
Well, it's not a small amount.
Yes, right?
All right. Well, I'm impressed.
Yeah.
How about you, Jonathan?
I'm more than impressed. This is a great demo.
For anybody in the audience who's impressed and wants to learn more, where will you send them?
Well, great. I mean, you can always just check out the storage page on Amazon, obviously, and FSx for Lustre is prominently listed there with basically what we talked about today, highlighted there. We'll also drop a couple links for a workshop and some customer references as well.
We love it.
Yeah.
Love a workshop.
Yeah.
Thank you. Thank you. Thank you both for being here. Laura, Marcos, it's incredible.
Thanks for having us.
We will be right back with more, so stick around.